All right, if everything has gone well, that means you have found this video and you are on step 1 of today's lesson, which says to go to Edpuzzle and to watch a video of me explaining some of the notes. So where we last left off was with this, and on this particular screen we found out that the location of the proton is in the nucleus, the location of a neutron is also in the nucleus, and the electrons are around the nucleus. A proton has a positive charge, a neutron has no charge, and an electron has a negative charge. These are things that should already be in your notes from the last class period. If they're not, feel free to pause this video and write any of this information down that you see fit. A proton has a mass of 1 AMU. A neutron also has a mass of 1 AMU, and an electron is very, very, very small for all practical purposes. It has no mass at all. You would need 1,836 electrons to be the same size as a neutron or a proton. The proton's job is to identify the atom. If you have 6 protons, you would then know that the atom is carbon. A neutron's job would be to keep those protons apart, because a positive charge and a positive charge would tend to repel, and the protons are just enough space to keep them apart so that they do not repel. Electrons are actually the things that are involved in chemical reactions. So the goal today is to learn how to use a periodic table to determine those 3 particles. Like, how do I know how many protons there are, neutrons there are, or electrons in an atom? So if you happen to have a periodic table like this one right here on this handy dandy super awesome periodic table of science, you can use this to determine how many protons, neutrons, and electrons there are in an atom. And it's not too hard. In order to determine the number of protons, you just simply find the atomic number. That's it. That's all you have to do. So if you had a periodic table, and if I'm hovering over the box magnesium will, if I can make my way over there super carefully, the atomic number is right here. Or if you're looking in the little box, it's also right here where I'm going to go on the mouse right now. So it's hard for me to get from here over to there to show you. So I'm just going to point to them in the little box when I'm on it. But the atomic number for magnesium is 12, which means it has 12 protons. The atomic number for vanadium is 23. And like I said, you can look over here, if I can get my mouse there. Right there is the atomic number. And when you have that atomic number, that tells you how many protons there are. The atomic number for aluminum is 13, so it has 13 protons. The atomic number for chlorine is 17, so it has 17 protons. The atomic number for mercury is 80, so it has 80 protons. And so on and so forth. The number of electrons, also the atomic number. The number of protons and the number of electrons has to be the same, because the number of protons needs to be offset by the number of electrons. Protons are positive, electrons are negatives. They need to cancel each other in order for the element to be electrically stable. So, on ptable.com, titanium has 22 protons, 22 electrons. Cobalt has 27 protons, 27 electrons. Carbon has 6 protons, 6 electrons. The hardest one to determine is the number of neutrons. And the reason the number of neutrons is difficult is because it's the mass number, but the mass number doesn't directly tell you the number of neutrons, because the mass number is a combination of the number of protons plus the number of neutrons. So that gets a little bit trickier to determine how many neutrons there are. So let's go to the periodic table and make sure that we can process this for a second. If I were to look at helium, now helium has a mass number of 4 and an atomic number of 2. I'm going to go up and I'm going to go all the way over here. It has a mass number of 4 and an atomic number of 2. So if 2 is the number of protons, you would have to add the number of neutrons to that to get to the mass number. So if it has 2 protons, it must have 2 neutrons in order to equal 4. If I go to lithium, you can take that 6.94 and round it to the nearest whole number, which would be 7. It has 7 things in the nucleus. 3 of them are protons, 4 of them must be neutrons. The next element, beryllium, has 9 things. That's what this number is it's really telling you how many things there are in the nucleus. There are 9 items in the nucleus. 4 of them are protons, so 5 of them have to be neutrons. Boron, there are 11 things in the nucleus. 5 of them are protons, 6 of them must be neutrons. So on the next page of your notes, I have a nice chart that I've made up where you could look up the atomic number and mass for all of those different elements. So we already said that helium is 2 and the mass number is 4, because I just did that as an example. If I look at chlorine on ptable.com, chlorine's over here, the mass number would be 35 and the atomic number would be 17. If I were to look at potassium on the periodic table, potassium is right here. The mass number is 39, that's the nearest whole number. The atomic number is 19. Vanadium, if I were to look at vanadium on the periodic table, the mass number is 51, the atomic number is 23. Copper, find copper on the periodic table. The mass number is 64. You would round up. That's a 5, so you'd round up. That's 64. The atomic number is 29. And finally, bromine. To find bromine on the periodic table, it's over here. The mass number would be 80. The atomic number is 35. Now, once you have those, if you know the atomic number is the number of protons and the number of electrons. That's what we said on the slide right before this. It's the number of protons and the number of electrons. If you know the atomic number, it's the number of protons and the number of electrons. If you know the atomic number, it's the number of protons and the number of electrons. If you know the atomic number, protons and electrons, protons and electrons. Atomic number is protons and electrons. The hard one is the neutrons. The mass number, subtract the number of protons, you will get the number of neutrons. Take the mass number, subtract the number of protons, you will get the number of neutrons. Take the mass number, subtract the number of protons, you will get the number of neutrons. Take the mass number, subtract the number of protons, you will get the number of neutrons. Take the mass number, subtract the number of protons, you will get the number of neutrons. Mass number, subtract the number of protons, you will get the number of neutrons. At this point, you have the instruction you need to be able to carry through for the rest of this class period. And the rest of this class period would be to do the things that are on Schoology. So for example, on Schoology, now that you've finished watching this particular presentation, you're supposed to work on assignment 17-9. Notice when you open that assignment that these columns, these items, might not be in the same order that they were just a minute ago in those notes. Pay very close attention to the column headings. Atomic mass is the mass number. The atomic number is the atomic number. Number of protons, number of electrons, number of neutrons. So be very careful with the headings on there. Be very careful. But you should be able to complete this chart with the instruction that you just had in the video. Once you finish that, you would continue on to step 3. Step 3 would be to go to Edpuzzle and watch a short video from Bill Nye on electrons and static electricity. Once you finish watching that, you could move on to step 4, And step 4 would be to complete assignment 17-10 in your homework packet. 1710 is very similar to 17-9, where the column headings might be in a different order than what they were in your notes, which is fine, because you should be able to adapt to that. When you find the element, you will have to look up its atomic number, the number of protons, the number of neutrons, the number of electrons, and the atomic mass. So for example, this one looks like it would be very challenging. As a matter of fact, I have this one in a notebook presentation so I can write on the screen. It doesn't appear like I have any way to identify what the element is that I'm supposed to be looking for. But it does tell me the atomic number. So if I go to ptable.com, and look for an element with atomic number 11, that is sodium, Na, with a mass of 23. Sodium, N, and I'm writing with a mouse, that's very hard, A, number 11 and a mass of 23, which means it has 11 protons, 11 electrons, and 23 minus 11 is 12. So let's take a look at the next one on that homework assignment. This is something that has 31 protons. So if it has 31 protons, right away I know it has 31 electrons, because the number of protons and the number of electrons always has to be equal. I also know the atomic number, because the atomic number has to be the same as the number of protons and the number of electrons. So I would go to ptable.com, find an element 31, looks like it's gallium, and then finally the atomic mass. Add those two together, protons plus neutrons is the mass. And you should be able to check that by looking on ptable.com. Gallium does have a mass of 70 if you round it to the nearest whole number. So there's a little preview of what you're doing today via the lesson overall. I'm going to go back to, if I can, go back onto the assignment. There we go, the assignment. So make sure that you get that homework completed. Do 17-9, watch the Bill Nye on electrons, do 17-10. You can really do them in any order. Make sure all of those things get done. And happy working.